Welcome to my week in astronomy. Things I found interesting this week in the world of astronomy and astrophysics. But this week I want to talk about the fact the Earth is the new mini-moon that we've just found. Our story starts with the Catalina Sky Survey in Arizona. It's a survey of the sky to identify near-Earth objects, ran by NASA and supported by the Near-Earth Object Observation Program. And in particular, one part of the survey is the Mount Lemmon survey, based at the Mount Lemmon Observatory in the Santa Catalina Mountains. You see, the Catalina survey includes a telescope at Mount Lemmon, another telescope near Mount Bigelow, and a follow-up telescope which is also at Mount Lemmon. Between these, they locate near-Earth objects. The Lemmon Observatory is very good at this. It's picked up over 50,000 minor planets as recognised by the Minor Planet Center. It's a useful and important job, categorising and working out which near-Earth objects may be a threat, which ones may hit Earth, for example, is of practical use to humanity. It's something that we should really be doing. But they also come up with interesting stories like this, where they've found us a mini-moon. On the 15th of February, Theodore Perrine and Caspar Wiekos discovered a new potential new mini-moon of Earth. They verified it, made more measurements, made more images of this object, and announced this to the Minor Planet Center on the 25th of February. It was recorded in the circular for the Minor Planet Center, and the discovery was checked and found not to match up with any objects of artificial origin that we know of. You see, the reason we call it a mini-moon is it's been captured by Earth's gravity. So for a while, rather than just orbiting around the Sun like any other asteroid or object might do, it went on a strange-looking journey because it's now really in the power of the combined gravitational effects of the Earth and the Moon as well as the Sun. The Earth and the Moon have a much smaller gravitational pull on these objects, but when an object gets very close, they have a vast importance to it. So that's the basics. What do we know about it then, and what can we find out? Now, we know how bright the object appeared in our images, and we can work out how far away it is quite quickly. For example, if you observe it with two telescopes at the same time, you can measure parallax, you can work out the distance. Once you have the distance and how bright it appears, you can get an estimate of its absolute magnitude, how bright it is. Now, once we have the absolute magnitude, we can begin to work out a few things about it. And I'll tell you now, its absolute magnitude is 32 in a number, and that's very faint. Quick converting in magnitude to luminosity to compare to the Sun, it's about 70 billion times less luminous than the Sun. It's a very faint object. But there's something else interesting we can do with this, which is we can estimate its size from that absolute magnitude. You see, how bright this object is going to be is going to depend on the amount of incident light on it. Some of that gets reflected back down to Earth that we see, and the amount that this is depends on the surface area of the asteroid, because of course that's what the Sun's hitting, and a value which in astronomy is known as the albedo. It's basically how much of the incident light on it gets reflected. So all we can do is say, well, around 3/4 of known asteroids are of a type called C-type, and they have very similar compositions and therefore quite similar reflectivities. So if we put in albedo values that are typical of a C-type asteroid, we get a diameter of around 2 meters to around 3.5 meters. This is why there's been a few news articles reporting that it's around the size of a car. If it is, as is very probable, that it's this sort of C-type asteroid, diameter of around 2 to around 3.5 is about the size of a car, I suppose. The other interesting thing we can do is track it. We can try and work out its position in the night sky for multiple observations and start making simulations of what its orbit was in the past and what it could do in the future. These are generally known as n-body simulations. Each body is an object, and there's a number of them, n. They aren't easy to do, but remember we have a good idea of objects in the solar system interacting. For multiple objects, the maths gets insane quite quickly, but we can make computers deal with it to a reasonable degree. And what I'm showing on the screen is a still from astronomer Tony Dunn's orbit simulator. I'll provide a link to it. Note that the simulation won't be completely accurate. The way these things work usually is to calculate in time steps. If you can tell where an object is now and the force is acting on it, you can work back to where it was some short distance in time back. But of course, the further back you go, the more small problems add up. And some parts of the orbit are more difficult to simulate accurately than others. So we don't have a completely good idea of the early orbit yet, to the sense that capture dates differ quite a bit, but we can say it was captured a few years ago, say around 3 years ago. We haven't got on this day the object came into the solar system yet. But now we know it is around, we have a great advantage. The more observations we have, the tighter we can make our simulations. So if we keep looking at this object, keep filling in more points with accurate astronomical data, the better and the closer to reality our simulations will get. And it's a very interesting object in its own right. Kasperyakos, one of the people who discovered it, pointed out in a tweet that while asteroids are incredibly common in the solar system, we've only ever discovered one mini-moon before, found in 2006. So it's a very interesting, very rare event. And also, it is kind of cute. I'll admit, the name Minimoon is beautiful. And it does make me think that, for a short time, the Earth has this lovely little companion. And one day, I think our simulations predict within maybe a few months' time, it'll leave. But until then, we've got a little friend. Until next time, goodbye.